Good morning, good afternoon, good evening. My name is Andri Widyawijatnoko. I would like to give the lecture about the humanitarian projects. And the content of my presentation will be divided into three sections, in which the first section will be talking about the key problem that impact humanity. And then the second about bio-based materials, and the third is about the architecture for humanity. I would like to start with the key problem, and the key problem that impact the humanity is the first is the natural disaster, leading to widespread of destruction, loss of life, displacement, and long-term socio-economic impact. So there are seven key problems that impact humanity, but I would like only to highlight the three of them, which is quite relating with the with my professional or volunteering project that I will present today. And the second problem, the second key problem that impact humanity is the poverty and inequality. A significant portion of the global population continues to struggle with poverty, lack of access to basic resources, and economic disparity, leading to a stark divide between the rich and the poor. And this picture show you how the poverty compels residents to construct buildings that are not up to standard, such as non-confined masonry, which is vulnerable to earthquake hazard as seen in Cianjur. This is one of the buildings that I've seen in Cianjur collapse because of the earthquake, which is not very big earthquake. It's only, not only, but 5.6 is considered not a very heavy earthquake. But the problem with the massive destruction in Cianjur because of the poverty in one side, and people tends to use or tend to build the building out of masonry construction, despite that they don't up to the standard for the earthquake. And another key problem that impact humanity is the climate change and environmental degradation. Yeah. Um, Human activities have led to the deterioration of the environment, including climate change, deforestation, loss of biodiversity, and pollution, which pose significant threats to the planet's ecosystem and well-being of future generation. And if you see the global carbon emission from the built environment sector by source in 2021 is in this case like 37%, which is uh, divided or uh, by the residential, uh, non-residential, building construction industry, and estimated emission for brick and glass. And this contribute like 37% of the global carbon emission. So this is very, very huge impact in our climate change and our environmental degradation. And if you take a look at this historical development of atmospheric carbon patterns, um, this is the atmospheric carbon and this is the terrestrial carbon. It was during this prior to revolution industrial revolution in 1750. The atmospheric carbons tend to be absorbed to the uh, to the as a carbon pool formation by the nature, by capturing by the trees and also the plankton and so on. But then since the revolution industry, all of the carbon that has been stored in the earth has been released back because of the uh, human capitalization and human industrial revolution. So all of this carbon that has been formed in the in the fuel, um, and also in charcoal has been released back to the atmosphere, and this is uh, uh, and we need to uh, start today. We need to capture all of the carbon that's been released in the atmosphere and needs to be captured in our building, yeah, in our building as a building materials. So in previously when we decided to build the buildings using concrete, and all of the structure using concrete and also using steel, it means that we release a lot of carbon dioxide to the atmosphere. Now we need to absorb all the carbon dioxide in the air and capture in our building as a building materials. So this is the era of carbon pool replenishment. And how to do that, yeah, how to make this decarbonizing building and construction through the avoid shift and improve approach. We need to do these three steps. First is avoid waste, build with less, and then make a shift to bio-based building materials, and then to make an improve conventional building materials and processes. And this is the things this one is the thing that I've done in and I've talked to I've presented right now. Now I would like to go into the second section, which is talking about the bamboo and the timber. So the recent advance in timber building materials technology offer the potential to replace carbon-intensive steel and concrete structure in some urban area with mass timber. This provides the double benefit of reduced production emission and long-term carbon storage in the building compared to mineral-based materials. Substituting conventional materials with mass timber could reduce global emission 14 to 30%. This is very, very huge impact if we can do this for our environment. We can improve a lot of our environment if we can use the mass timber as a replacement for using the high emission carbon high emission like steel and also concrete. And in the other side, bamboo is considered to be the front runner for driving afforestation practice to mitigate climate change. Global studies of the annual carbon sequestration capacities of bamboo range from 10 to 24 tons of carbon per hectare on the lower end. This is 1.46 times the sequestration capacity of forest and 1.33 times that of tropical rainforest. And unlike the carbon sequestration losses associated with the timber logging, selective bamboo harvesting may be less ecological damaging to the forest, and productive species can yield between 150 to 296 ton per hectare of forest plantation land. And this is how we need to change uh, the way we think of the way we think of steel and also concrete. So we can, if we can do it with the bamboo, then it would be a lot of impact to our environment. So in the section 3, I would like to go on with the architecture for humanity, in which that I divided also into uh, some structure that I've built after the earthquake. So first is the temporary shelter and the mosque. Uh, as an architect, we need also to think about the uh, the very unfortunate people, which is, for example, affected by the earthquake. This is the example of the refugee after 5 years after the earthquake in Cianjur. I've mentioned you before, Cianjur has been hit by the earthquake. It's not very big earthquake, but the devastation is very bad because of the poor quality of their building structure. So they need to move from their collapsed house into the shelter, and the quality of the shelter is very bad. And as an architect, learning from the traditional bamboo construction, and then I try to use, learning from them, I try to use the simplest bamboo joinery using only plastic ropes with a drawer. I can connect bamboo like this. Uh, we can even make this hole very easily because bamboo is only longitudinal fiber, and using the manual saw, we can easily make the hole like this. And to make the fish mouth joint like this, yeah, we can just simply make a cutting with a machete. We can also make this cutting with a saw. And then after we have like this, using the plastic rope and the drawer, we can tighten the structure like this. It is very, very simple and also very easy to do. And prior to go to Lombok after the earthquake in 2018, I and my student conducted a workshop in our school, in our university, and we make the prototype of this temporary uh, family shelter. So we use 11 pieces of bamboo with the same length, yeah, with the same length, and then we use a kind of reciprocal frame configuration. This is widely known as Da Vinci bridge configuration. And after we make this kind of connection, everything can be done on the ground. It's very easy. Then we lift this up and push this one inward and the next step is we have like an A-frame like this, and then we tighten in the crossing like this with the ropes. And then after that, we can cover this one with the tarpaulin. So this is the process that we did with our student in our backyard of the campus, and we covered with the available tarpaulin at that time. We only have like this, but it's, yeah, I would like to show you how the structure is very light. Yeah, it's very light. It can be lifted only with four men's. Later on, you will see how easy this one to be lifted and then move to other places wherever it is needed. Yeah. So it is quite strong enough also. Not not very strong, but it's strong enough as a refugee shelter. And after those workshop, I've sent my student also to Palu after because previously Lombok hits by the earthquake, and after a couple of months, the earthquake hit Palu, and the casualty is also very big there. So I sent also the student to go to Palu to build this one to try to educate the people and trying to offer more comfortable family shelter for the refugee. And and this is the example. And I've built also in Lombok this structure. um, Previously I didn't use the common tarpaulin, but I already make the measurement and everything has been shoot prior to build it, so it will fit with the A-frame. I even stay in this shelter for 2 or 3 nights in Lombok. It is not the best. It's not provide the best comfortability, but of course it's more comfortable compared to the shelter that's been built by the people in Lombok by themselves. So, and after the earthquake in 2023, sorry, the earthquake happened in 2022, the late 2022, and then we built many bamboo shelter also for the people there, because the need is very, very huge. And we were very lucky to be helped by the uh, military. Yeah, military. We teach them how to build the A-frame shelter. Yeah, using the very simple connection like this. And then because of the disciplinary of the military, then they can build many places. The replication is very, very heavy in there. So even we built in a certain location as a workshop for building this shelter. And after we finish, then we move to the place wherever it is needed. So you can see that this can be lived only with even with only four uh, people after it's already finished. Yeah, you see here we built this with different with the previous one you saw in Lombok. In here we use the available tarpaulin, in which that the one of the tarpaulin is built for the building, sorry, for the to cover the wall, and the other tarpaulins using for roofing. So basically, this only used without pre-shoot tarpaulins, just using the available tarpaulin that is already in the place. And oh yeah, in here you didn't see also the ventilation. Later on, I will show you our development to make the ventilation in this tent. But you can see here we built in many places, and then we send to the people that is needed. Yeah, and this is the compound of the refugee using our tent. Uh, we work with the uh, we work with the NGO there. We call it as Rumah Amal Salman, and we built a more than 140 small shelter. Yeah, 3 to 4 meters square meters, and then with the height of 2.6 meters. And even we built 3 big shelter, 5 to 5.7 meters, with the height of 4 meters. This is needed mostly for replace for the temporary mosque in Cianjur. So in here you can see that the development from before and after our program in building the shelter is quite huge. Yeah, you can see the previous condition like that, and then we can have more comfortable place of living. Yeah, much higher space, also much bigger space inside the building. And in the earthquake, in recent earthquake in 2024, we also built 6 uh, structure like this. Yeah, a strict structure like this. And then we make an improvement of making the ventilation. We provide the ventilation, including the mosquito net in here, and we provide also the ventilation of for the light, for light ventilation. So basically, they even can close the here, because the ventilation already been there, since the place in here is not really hot. It's actually quite cool, even at noon. Yeah, so it's better for them to it's even can close this big window because of to make it more comfortable. And we built also another example here in front of the governmental building in here. Try to promote the use of this shelter, so the donors can go and build this one, and ask the local to build this one. Yeah, so because the bamboos also have been botched in this place, also the tarpaulin is also using local tarpaulin. It means that with this kind of shelter, we can also give or we can also improve the economic the economic in the local economic after the disaster. So yeah, this is from Rumah Amal Salman, the sponsor for many of the building here. And in this case, we teach also two local worker to build this shelter, and then after we teach them how to build it, they can build by themselves, and then they can also make. We teach them also how to make this ventilation, air ventilation, and also we teach them how to make the light ventilation in here. So not only with the small or small shelter or family shelter, we build also the big shelter for mosque, for general kitchen, for the class, and other purpose. This is the example of the uh, this is the example of the big shelter that we built in Cianjur. We can solve the problem with the span. We can solve the problem with the rigidity against the earthquake. But the problem with this big structure like this is the wind. Yeah, because it's very light, and it's yeah, basically it's closed, so it's really easy to be blown away by the wind. Therefore, we need to reduce the height of the building. So in the end, we need to cut and reduce the height. So we built a much smaller shelter. However, it's still big enough for community to stay there after the earthquake. And this is another example also in Cianjur, with the help of the army. Yeah, we built many big shelter, and because of our previous learning from previous experience, which is quite easy to be blown away by the wind. We need to use more a reliable joinery in this case. So we use the threaded rod or bolted joint for this construction. Although we make it also very simple, everything's done prefabricated, and then after that we teach them how to connect these two together, so we can build the mosque in here. So this is basically quite big space for the mosque, because the mosque is also collapsed because of the earthquake. So this is after the praying, uh, uh, Friday praying in the mosque. So up to 11th of December 2023, we built like nine shelter, nine big communal shelter like this in total. So with a very big span, like 8 to 14 meters, with the height of 4 meters. So this is uh, the things that we can reach in there, we can build in there. So this is yeah, this is actually work of many stakeholders, and also some of them is also my students in ITB. And going back again, from the earthquake in 2018 in Lombok, uh, this is probably the prototype of the smaller scale of community shelter. Uh, with the help of my student at that time, Gilang Nugraha, I sent him to Lombok, and then he built the shelter in Lombok with the community, teach them how to build it, so they know how to build it with this with the simplest connection that I've um, already touched to Gilang before. And yeah, this is one of the shelter that has been built in Lombok. And we built, I also, my student also go there and build the command center for ITB, and also from the local university there, Mataram University. So we built this structure, a very huge structure, using only the smallest or the simplest connection with uh, the plastic ropes. Yeah, and it's quite become very useful for many occasion in there. uh, yeah, it's become like a command center for from our university and also the University of Lombok. And we built also the same in Palu. Yeah, we built also the same in Palu. Uh, this is the biggest structure at that time in Petobo. If you heard about the liquefaction, actually, we built in the location of the refugee from the victims of the liquefaction in Patobo. So it's like a flat area, and we built the biggest structure in here, and it's really, really useful actually. But the problem is the very, very uh, big winds, because it's like a flat and it's exposed, and there is no big tree in surrounding area, so it's really, really uh, have a problem with the big wind, and the quality of the bamboo is also not very well, and it was collapsed because of the wind. And then I need to rebuild again. You see that this is other shelter, refugee shelter. uh, People rarely really stay inside the shelter during the days because it's very, very hot. They prefer to stay inside the big shelter that we built with the bamboo. However, it was collapsed because of the wind, and also the kids are climbing the structure. So we need to build a more sturdy structure, and then we change it into the timber construction, since the timber is much easy to be found in Lombok with a sorry in Palu with a better quality. So we changed the idea from bamboo into timber, and this is the frame that we built. Everything has been done on the ground, and after we finished the the frame, and then we erected the frame one by one. So I even need to help them uh, to yeah, to make sure that the structure is also stiff enough, uh, And yeah, this is also become the biggest structure in Patobo at that time. Yeah, you can compare also this one with another tent here. So the afterward we covered this one with tarpaulin. And after we finished the first shelter, I left four of my students to build another in Palu, but in different refugee area. So they know how to build it with the help of two other worker, two more worker in Palu. They built the second structure, and they can finish from the start less than 5 hours. So less than 5 hours, they already reach this kind of structure. And in this case, we covered this one with the corrugated metal sheet because we want to use it more. Uh, we expected to have more lifespan of the structure for the people to use this building. So yeah, this is very important. The structure, which is like a medical treatment, happens also inside the structure. So and then it was moved to the other places and become the temporary mosque in there. So it's really useful for the people because at the times it's also like the biggest structure in the area that can be used. So there are many programs happen in this building. And then after Lombok, Palu, and then the earthquake happened also in Mamuju, yeah, during the COVID. So at that time I couldn't travel because it was like everybody has been locked down in the house. So Mamuju is like 9 hours from Palu. So I have many. I still have volunteer that previously built, also helped my student to build this frame shelter, and I asked them to help me to build uh, four of the shelter in Mamuju. So they agreed to do that, and then uh, everything has been prepared in Palu. So they already pre-cut the timber in Palu, and then after that, yeah, after they pre-cut the timber, and then they transported the timber to Mamuju, and then they erected in Mamuju. They built it in four places in Mamuju. So and after the reconstruction has been finished, this has been brought to be used as a kindergarten in Tapalang in Mamuju. So from previously it's intended to be a non-permanent structure to become like a permanent structure. And this is another yeah, this is the same this is another shelter which has been built in Mamuju in 2020 by our volunteer at that time. So using the same principles, after the earthquake in Cianjur, one of the health center in Cianjur has been damaged quite severe. So we need to build another temporary community health center, or puskesmas we call it. And we build it with the same principles. So we use the timber, and we need to build in this very very narrow site. And then using the same principle, but it's quite big, so we can manage. And then we built the new um, uh, Puskesmas in here. Yeah, it's been used to replace the previous one. And I think one of the kids was born in here also during that time. So yeah, this was uh, the cooperation between Rumah Amal Salman Research and Community Service Institute in ITB and our School of Architecture, Planning and Policy Development. And some of my ex-student and also my student helped to build this one also. Okay, and then we move to the next the same section, but I would like to show you about the plastered bamboo construction. So this is also one of the technology that is intended to be used after the earthquake. So the why plastered bamboo construction? Because almost no one in Indonesia wants to live in bamboo house anymore. The problem is the image of the building, which is considered as a non-permanent. This is considered for poor people, so that at least maybe almost no one wants to live in the bamboo house anymore. So in the other side, people tends to uh, people tends to make masonry construction. So this is the example of the structure that has been found in Jatiroto. It was built uh, by by the Netherlands, by the Dutch colony during the colonialism. And actually, the buildings looks like a masonry construction. However, actually, it's made out of timber skeleton and then covered by woven bamboo and then plastered on the outside. So that's why plastered bamboo construction is basically trying to provide common image of permanent house, but using bamboo, and don't and uh, do not use uh, the masonry or brick. So the other reason is we can use the low quality of bamboo production, because in the end uh, we can hide low quality of bamboo. And this is also an alternative of pressure of bamboo preservation technique by protecting against rain and moisture, and also preventing the entry of the fungi and also the beetles. The other thing is plaster bamboo construction also improve the fire resistance and also control the interior thermal. Yeah, in some cases it's also very important, although most of the time, especially in tropical countries, probably it's better to have like same thermal condition between the outside and the inside, because in some places the thermal condition on the outside is also not very hot or quite calm. So the idea also of plastered bamboo construction is to provide the uh, the housing uh, by reducing uh, the the waste. Yeah. So the common conventional method after the earthquake happened, there there are was a there were the refugees, and people tends to build the emergency shelter, and then it's become the waste when they build the new house. Using plaster bamboo construction, we can make a prefabricated bamboo panels, and then with this prefabricated bamboo panels can be used as a bamboo emergency shelters in the safe location in the refugee area. And then after the relocation, we can build the semi-permanent bamboo house using the same bamboo panels. And after uh, plastering, it becomes the plastered bamboo house, which can be also considered as permanent house. So the idea is making the prefabrication of like this, and then after that we can make the plastering, and then we have like as in the common image of permanent house. And this is the first prototype that have been built in 1999. uh, so everything has been done outside the site, yeah, and everything has been built in here, erected in here. After that we make a plastering to have this 36 square meters permanent house. So everything has been done here in the workshop. Actually, the workshop has been done in 300, more than 300 kilometers away from the site, because at that times because of many things, many factors, it was built. It was made in Purworejo, in my hometown, including the wall frame and etc. And then I brought all of the modules in the site, and we erected here in a day, so we can have like a day to erected all of the structure here, because using only very simple joinery, lacing joinery, and uh, and then it takes quite time, like probably a month to plaster this one, because plastering this one is also uh, it's new from for the worker, so they are needs to learn first before they can do it fast. Yeah, so in the end, we have like construction. So this is another project that have been built in 20. Oh yeah, this building is 1999, and in up to date, the building is still there. So it's already like 25 years old. And this is has been built in 2005. Yeah, it's 2005, and a couple of maybe last year, a student of mine take a look at this building, and it's still there. So already like 20 years old. So this is has been built in 2005. However, it was uh, 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 it was demolished. Yeah, it was demolished because there are project happens in this area. Yeah, from this is uh, the last picture that you've shown. I use the different types of this walling system. So in here, I use the flattened bamboo as a wall. Yeah, and then I need to put the chicken wire uh, to improve the quality, and also to improve the speed of plastering process. Yeah, this is another project. It's also a very like one of the first project also built in the same time in 1999. This was built after the earthquake in Sukabumi, uh, and my student collecting collecting the money from the donors, and then they built the house in there. And in 2019, my student came back and see the building is still there. So it's already like 20 years old. Yeah, and it's still in the good condition. And recently I built the new structure with my master students. And since the site is very small, it's very difficult to make a kind of prefabricated. So because it's going to be difficult to distribute the modules, it's better to distribute the bamboo in this in this to distribute bamboo poles is much easier compared to the bamboo panels. So we built actually on site. Yeah, we built all of the modules on site, and then we erected one by one like this. Yeah, and we use some back bamboo, because back bamboo has quite exotic skins. And with this black bamboo, we only plastered on one side, and we expose the other side. So it will provide a very nice texture on the outside. So you can see this is after the finish of the structure. Uh, you see that some of the wall we didn't we did not plastered. We want to keep like this to show that uh, actually the wall is not made out of brick, but the wall is actually made out of this woven bamboo. So yeah, this is the owner of the building, and this is my student. This is the also a friend of mine that helped me to build this building. And another structure that I've built after for post-disaster reconstruction is this combination between bamboo and ferrocement. Ferrocement is widely used very long time ago, but it's never been used recently. But I've seen that uh, it can be combined together to make this I call it a rumah bamboo ferrocement or bamboo ferrocement house. So the idea is very simple. I have like bamboo crossing each other, and put in the middle this chicken wire. Yeah, put the middle chicken wire, and I use the bolte joint to connect, and I make everything almost same like this as a wall modules. Yeah, using a bolte joint and then connecting everything like this. Even you see that I have a door here, but the door is not open yet, so I let the bamboo go on. This is important for transporting, and you see that the modules is uh, this is like 1 meter each, like 4 meters to 3 meters, and another is 3 meters to 3 meters. So we're transporting everything like this, and then sending. Actually, it's happened in East Java, and I made this one because of I need to teach also the worker. I need to teach also my student how to do this. So everything has been done, everything in Bandung. So it's uh, uh, like maybe for 400 kilometers away from the site of the workshop. So it's far away, but yeah, uh, I see this one is the best way because of many consideration. And then the good thing is the people in there is also very happy to help to build this one. Although this is very new also for them, they want to help also one of their members in the village. So after that, we can finish the building here, and this is the owner of the building. She's very happy that we built her her new house. And then quite similar, but in different types of materiality, I built timber and ferrocement. The idea is the same, combining timber and also ferrocement, and and in the middle of between the crossing timber is this chicken wire. Yeah, and nailing. Everything has been done very simple and very easy. And prior to erect this one, we built the foundation, the simple foundation, and then we send this one, um, and then we build it. We discuss also with the person uh, uh, who will use this building, and then with the help of the people there, we simply erected this kind of structure. And then after that, uh, building erected, the frame is very simple and very easy, but then uh, the problem or the challenge is how to apply the ferrocement. Yeah, because it means that we need to plaster this chicken wire. So it's a lot of work to do, but in the end they can manage to build it. You can see that in one side we only see uh, timber in one direction, and in the other side we see timber also in the other direction. So this is the way it works. You can see this is the final result of the building. And this is another community center in Cianjur after the earthquake. I also have worked with a student, and we collaborate with the University of Florida, ITB, and University of Florida, make a workshop together, and we built this kind of gazebo for community shelter, because they don't have any open space. They don't have any building that is big enough for them uh, to conduct uh, like a program or anything. So we decided to build it in here. Uh, First, the student needs to work, and then uh, after that we uh, make a kind of uh, jury, and then we choose one to be built, and this is the final result of the building. This is another project of mine, community healthcare in Jatiluhur, using the planar frame. The owner is Nurani Dunia Foundation, and basically we also try to promote the use of bamboo in that area, because actually Jatiluhur have a lot of bamboo, but most of the building there has been built using masonry construction. So this is the structure that has been built, and this is another project after the earthquake in Cianjur. I've built a shelter, but then I've built two permanent structure. One of them is Al Barokah Mosque in Cianjur. Yeah, this is not finished yet at that time, but actually already finished. But I haven't updated this presentation yet. And the other is the mosque also in Cianjur, Serambi Salman Cianjur. The previous mosque collapsed because of the earthquake, and then I built the new one, and everything. Actually, the spiritual leader also of the mosque is also very much eager to have a bamboo building in the area. So we are very happy to collaborate. Yeah, and yeah, this is the the skeleton was made out of concrete, but the roof structure is made completely with the bamboo. So this is the final result of the structure. Yeah, you can see the complexity of this of this roof structure as span to reach the span of 30 meters. This is the building. Now it's already completed. And another bamboo building that I want to show you is the mosque, Anur Aceh Lombok. So the completion of the mosque is in 2019. I try also to calculate how many carbon dioxide has been stored in this building, and approximately like uh, 3.2 tons of carbon dioxide are stored in the approximately 250 meters of bamboo with average diameter of 10 centimeters, assuming the carbon content of 47.5%. So this is also needs to be aware of. One of the reason using bamboo is absorbing the carbon dioxide inside the bamboo. So everything has been started because of the one of the mosque collapsed because of the earthquake, and this was the mosque, Anur Mosque, and then I tried to uh, make a proposal on how to build this one with bamboo. This is the very common. This is the very common, well-known rice to store the rice. To store the rice in Sasak tribe, the local tribe in Lombok, and I'm imagining to have this kind of form. But I already have also many experience of conducting reciprocal frame construction and also this truss construction. So this is the development from the Da Vinci Bridge into something become the structure of the mosque. And I've asked also my student at that time, Imam Prastyo, to help me to make an image of the building, especially to have permission to build this one from the local community there, and also from the financial sponsor, which is the people and also the government provincial of Aceh. And we built also the model. We make the model. Why? Because the model is needed to communicate with the worker, um, and then after that we build it in the real scale. So everything has been done also like a semi prefabricated. Yeah, so we built one by one modules, and after we finish, and then we lift this one on top of the pedestal, and we then make it a layer by a layer, and after we finish, we covered with the tarpaulin to provide more comfortable environment inside, because Lombok is very hot. And then, yeah, one by one we finish the structure from the inside. So this is uh, on the day of grand opening in 2019, uh, and this is during the first praying Friday pray after the inauguration. Yeah, this is after we finish all of the structure of the mosque. And another is the timber mosque in Mamuju. Since Sulawesi has a huge potential of coconut timber, yeah, I make a proposal on designing the whole structure out of coconut timber, and I try also to estimate the carbon dioxide that has been stored in the building. So approximately like 44 metric tons of carbon dioxide has been stored in this 24 cubic meters of coconut timber, assuming the carbon content of 50%. So in this case, I also use only one size of raw materials, which is using 5 to 10 centimeters cross section of timber, coconut timber. So you will see that, and then I make the configuration of a truss system in here. So everything has been done on the ground and then lifted one by one. And this is after the finishing of the structure. And then the last is, I would like to show you the timber mosque in Nurul Hasanah, Palu. So this is the biggest timber structure probably that happened also in Indonesia. The completion of this building has been in 2020 in Palu, Indonesia. It was estimated that 77 metric tons of carbon dioxide are stored in the 40 cubic meters of hardwood, assuming a carbon content of 52%. Yeah. I try also to introduce the laminated timber, although in this case we laminated the hardwood, but actually since our structure based on the lattice structure, in some places I need quite big beam for the main structure. So in this case, I need the dimension of 9 centimeters of thickness and 60 centimeters of uh, the depth, yeah, or the height of the beam. So I combining the raw materials is 3 centimeters to 30 centimeters. Yeah, this is the raw materials that we have. Then to provide those dimension of the beam, we need to make it into a kind of uh, laminated, yeah, lamination. So we combining like this. We cutting half of this and putting 15, 30 to 15, and this is 30 to 30, and then we combine with using we use a lot of glue and also screw to make this one. And then we use also a kind of clamp to make sure that it will work together as a beam in the end. And the weight of this is almost like 1 ton. And I'm very thankful for the worker here. They worked very, very hard, and they lifted this one only with a tackle, without any mobile crane or on other heavy equipments. Everything has been done manually. Yeah. And it was also connected by this kind of joinery. Yeah. Steel plate joinery like this. Yeah, and this is 60 to 6 centimeters. So we combine two layers of timber in this case. Yeah, in the end, you see this structure, and you can see also the scale of the structure in comparison with the people who works above. So you see how big is the structure, and this is the inside of the building right before the inauguration or the grand opening in there. So after the inauguration, I was invited also to talk to the student from the local university there, to talk about the concept of the building. And yeah, this is the picture of the building inside, and this is uh, from bird eye views. And thank you very much for your attention. I hope all of my presentation can inspire you also to work not only using the conventional materials, but I hope you can get inspired also to use bamboo and also timber as your main construction. And also, I hope that uh, all of you or some of you can also work in a kind of volunteering project to help people, because we are very grateful that we live like this. We are very educated. Many people needs our uh, uh, experience and also expertise to help them with many ideas and with our creativity. Thank you very much for your attention and see you again next time. Bye.